We did our presentation on CAD standards. My name is Amelia Chan.
I'm Stephen Carletto.
I'm Daniel Saravala.
Stephen Lang.
I'm John McCleary.
And I'm Matthew Shapiro.
So the current version of the United States National CAD Standards is version 6. The standards streamline exchange of building design and construction data. It allows for the industry as a whole to coordinate communication efforts efficiently for project development. It reduces costs for developing and maintaining office standards, and adaptation of the National CAD Standard is completely voluntary. There are 4 parts that make up the National CAD Standard, which are the American Institute of Architects CAD Layer Guidelines, Construction Specification Institute's Uniform Drawing System, the National Institute of Building Sciences BIM Implementation, and Plotting Guidelines. The National CAD Standards brings many benefits to various workers, including the engineers and architects, as it allows for consistent data classifications for all projects, simple transfer of information, and reduced file formatting and setup time. This benefits contractors because it has consistent sheet organization and detail reference system, and a reduction of error, discrepancies, and delays. For clients and owners, consistent data organization comes from all the sources. There's clarity of communication of design intent, and facility management data is all streamlined.
And now we have a short video on why CAD standards are important.
Hi, I'm Kate. I'm here with Yoshi from US CAD. So Yoshi, when you ask your participants in this class, why is standardization important? What kind of answers do you get?
Well, we get a different array of answers, and it's great to put different groups of people in there, especially different disciplines of people together, because then they get a different view or overview of the whole thing, and it's not so much in their own little fishbowl. But we get the common things. You know, I think the number one thing that always comes up is consistency. Just having some kind of consistency that will help them with ease of use, will also help them with some type of efficiency or productivity gains because of that consistency. And a lot of those consistencies then go back into something else, like how do you make that consistent or whatever it is. Yeah.
So they're trying to do it right rather than do it twice, right?
Right. That's correct. Yeah. And some other things, obviously, you know, all the different things that are important. They start to now talk about a little bit about because of interoperability, you know, where before it was just one product and now we have vertical products. So just interoperability and how standardization and consistency will help you do that. Also presentation is a big thing. Now that some people are using multiple products or just being able to submit or present your work in a consistent manner throughout. Nowadays with smaller workforces and things like that, you know, it's just easier for it to look not as identical as it should, and so that consistency stays there. And then of course training, keeping your current employees up to date with standards and things, and then also being able to get new people on board right away and get them right into the project because things are just consistent.
Definitely a lot of great reasons.
Yeah.
Thanks.
In order to implement the NCS, you must buy a license. The rates depend on a number of users per license, and they vary from list price, member price, academic/government price, and student price. And below is a 12-step implementation program from their website. Here's a quick video introducing the National CAD Standards and its definition.
The National CAD Standard (NCS) is a collaborative effort in the United States among computer-aided design (CAD) and building information modeling (BIM) users. Its goal is to create a unified approach to the creation of building design data. Development of the NCS is open to all building professionals in a collaborative process led by the Building Smart Alliance. The NCS is composed of CAD layer guidelines from the American Institute of Architects, Uniform Drawing System modules from the Construction Specifications Institute, and BIM implementation and plotting guidelines from the National Institute of Building Sciences. Adoption of the NCS is voluntary, however, adopting companies and agencies can require its use by their associates.
AIA CAD layer guidelines. They need to be followed when creating an AutoCAD layer name. The CAD layer guidelines, they're made up of 4 different layers, which is the discipline designator, major group, minor group, and status. The minor group can also be split into 2 subgroups. The discipline designator and major group are mandatory. However, the minor group and status are optional. An example of the CAD layer name is shown in the image below, which is AI, wall, full, dims, N. And as seen, each section of the layer represents the 4 different layers. The full AutoCAD layer name being represented is architectural interior for the discipline section, wall for the major group, full for the minor group 1, dimensions for the minor group 2, and new work for the status. Discipline designator level 1 and 2. Discipline designator is used to identify the types of work included on drawings. This helps organize drawings and makes working in a team environment easier by allowing specialized works to find their specific drawing. For example, a plumber can find his drawings easily by just looking for the letter P. The table on the left shows the mandatory discipline designator, which is represented by 1 character that corresponds to the discipline. And on the right, the table shows the optional discipline designator, which goes more specifically into the discipline, represented by 2 characters. Major group. The major group is used to identify the overarching building system that the layer falls into. As seen in the table below, the major group is represented by 4 characters that correspond to the building system. These are just some of the most common building systems, but there are a lot more. Minor groups, as mentioned before, the minor groups are optional because they're meant to help further define what is contained in each layer of the major group. Some examples can be found in the table located at the bottom of the slide. With minor groups, you're allowed to use whatever name you want to define the layer. It just has to follow the rules of the major group so that the name can only use 4 characters and only 2 minor groups are allowed. Finally, the status. The status is used to define what the construction status of the work is. These construction statuses are predetermined and again optional. As seen in the table, the construction status is found on the right with the corresponding character found on the left.
The uniform drawing system. Uniform drawing system. The Construction Specifications Institute, or the CSI, created the drawing sheet naming system in 1994. It's called UDS for Uniform Drawing System. The system uses 2 characters followed by 3 digits. 2 examples are seen below: AS102 or P-101. The first position in the uniform drawing system is the discipline designator. All of these are all of the examples that can be a discipline designator. So for someone in civil, they would be using a C. For someone in telecommunications, they would be using a T. And most of these discipline designators are the first letter in what they represent, with some other cases. The uniform drawing system position 2, in most cases, the second position is just a hyphen. When a character is used, it modifies the discipline designator. Some examples are AS would mean architectural site, CD would mean civil demolition, and EL would mean electrical lighting. Uniform drawing system position 3 and 4. The sheet type designator is the third position. So seen below are all of the different types of sheet types, with 0 being general symbols, legends, and notes. Number 6 would be schedules and diagrams. 7 and 8 are user defined, so those can differ on all different types of drawings depending on what type of category they need to represent. And number 9 would be 3D representations, with that being isometrics and photographs. The fourth position in the sheet sequence is the page number. It starts at 01, followed by 02 through 99. 00 is not permitted.
The National Institute of Building Sciences implemented a BIM, which is Building Information Management System. And BIM use is a method of applying building information modeling during a project's lifetime in order to achieve its goal. This technology allows owners to use the model in many different ways depending on the project's needs. As the project progresses into further phases, information in the BIM increases and becomes increasingly specific. Uses can be characterized essential, enhanced, or owner-related. So the essential BIM uses are existing conditions. This is the process in which the model of an existing site is developed. So basically in this process, they're taking the original location in which they're building the whatever building they want, and they are then mapping this and modeling this. Design authoring, this is a process in which software is used to render a design. This would be used in like the early design stages of the project. Design review, this is where stakeholders would review the design to see if it would meet all the criteria to what they were hoping for. So this would cover everything from the initial plan, everything from what they wanted the outside to look like, all the way to the interior of their design. Coordination, this is where model elements are organized and coordinated. So this is where lots of construction would take place, getting everything ready for like the final opening or the use of this project. And then finally, record modeling, which is a process in which the model is updated to have an accurate depiction of the site at any given point in time, and it's constantly updated. So this will be done throughout the entire project's lifetime. It will be constantly updated until either a new building is made or an entire new BIM is made for a new building. Enhanced BIM uses, these include cost estimating, phase and 4D planning, site analysis, digital fabrication, 3D location and layout, engineering analysis, sustainability analysis, codes and standards compliance, and construction systems design. These are all more specific ways that you can use BIM. These will all be put in subcategories under the main categories that were described in the previous slide. As shown in the in-depth BIM example, all of the previous uses are all modeled in the overall example. Some owner-related BIM uses would be asset management, disaster planning and management, and space management. And these are just smaller uses to have the most accurate model.
So here's a quick video about building information modeling.
These days, a growing number of architects, engineers, and contractors are using BIM. And here's why. Global trends are making AEC projects more complex, while advances in technology are helping industry professionals work more efficiently and effectively. This is where BIM comes in. BIM is an intelligent model-based process that connects AEC professionals so they can more efficiently design, build, and operate buildings and infrastructure through BIM, or Building Information Modeling. With BIM, designers create digital 3D models that include data associated with physical and functional characteristics. The power of BIM is how it allows architects, engineers, and contractors to collaborate on coordinated models, giving everyone better insight into how their work fits into the overall project, ultimately helping them to work more efficiently. The data in a model defines the design elements and establishes behavior and relationships between model components. So when an element in a model is changed, every view is updated, with the new change appearing in section, elevation, and sheet views. You can use the information in the model to improve your design before it's built. Gain faster buy-in and approvals with realistic visualizations. Convey design intent to the field. And, most importantly, retain model intelligence from concept to construction. BIM provides insight into a design's constructability, improving the efficiency and effectiveness of the construction phase, and also providing a better understanding of the building's future operations and maintenance. Owners can use BIM for predictive maintenance, asset tracking, and facilities management, and for future renovation or deconstruction projects. When you work with BIM, you'll experience reduced project risk, improved timelines and cost savings, and better project outcomes. And the power of BIM is growing with cloud-connected technologies that let project teams design and work together in all new ways. Driven by global trends, the AEC industry is in a time of transformation. Businesses that want to win more work, deliver projects more efficiently, and design better buildings need a powerful solution. And that solution is BIM.
Following plotting guidelines will ensure that you have a successful project. Different line sizes vary depending on what printer you are using or what you might be printing. Common line sizes vary from 0.13 millimeters up to 2 millimeters. It is important that while you are going through your plotting, you choose the correct paper size, the plot orientation, and other settings before printing. It is also important that you confirm that your units are correct before you print, or else your project might not come out as you want it to.
So in conclusion, throughout this presentation, we went through the ins and outs of CAD standards and just go over some of the main points, went over the benefits for different groups of people for CAD standards. We went over the implementation of CAD standards through the NCS and their 12-step implementation process. We went through the 4-layer CAD guideline systems, which was the discipline designator, the major group, the minor group, and the status. The major group outlined the overarching building systems. The minor group went to further define that layer. The status defined the construction status of those layers. And then we had the uniform drawing system. It was created by the CSI, the Construction Specifications Institute. It's called the UDS. Then we went through the different positions of that. So we had Universal Drawing System Position 1, which was the discipline designator, then Position 2, which can be a hyphen or could be used to modify the discipline designator. And then there was Position 3 and 4, which is the sheet type designator. Then we went over BIM implementation, the essential BIM uses, which were things like existing conditions, design authoring, design review, coordination, record modeling, then enhanced BIM uses, things like cost estimating, phase and 4D planning, owner-related BIM uses, asset management, disaster planning and management. And then lastly, we went over the plotting guidelines, which is just going over different units and stuff. And yeah. And then we just want to say thanks everyone for watching our presentation. Here are our sources.